Welcome to my projectbazaar.com. We discuss about degrees of freedom for the 2-cell 2-hop MIMO interference channel interference free relay transmission and spectrally efficient relay line protocol. This paper considers the 2-cell 2-hop multiple input multiple output interference channels where two source group consisting of multiple user with a single antenna wish to communicate with two multi-antenna destination by sharing two multi-antenna relays. For such a channels, an inner bound on the degrees of freedom is derived for different channel knowledge assumption and relay operations, assuming global channel knowledge at the relay and full duplex relay operation. It shows that two cascade interfering link can be decomposed into two independent parallel relay channels while sharing the spectrum. The key to showing the result is a novel amplify and forward interference free relay transmission method, which performed interference shaping during reception and interference neutralization during transmission, assuming that the relay have global channel knowledge only for the first hope. A spectrally efficient relay line protocol is proposed that overcome the losses due to half duplex relay line constraint. The proposed protocol improves the performance compared to a trivial time division multiple access method for the 2-cell 2-hop MIMO interference channels. Now let's demonstrate the data flow diagram. It consists for transmitting, relay hopping, beam forming, destination received signal, degrees of freedom and receiver. First of all, the transmitting signal is given into relay hop channels. The relay hop channel performance consists of two source, two destinations and two intermediately relay it channels. Having the multiple channel antennas, we allocating the separating the data into several channels. The output is given into beam forming method. In this beam forming method, indicate the relay beam forming matrix with the size of m cross n is the power normalizing factor to satisfy the average relay power concealed. Therefore, the power normalization factor is defined as second hope and the first hope of the signal factor. The signal factor will be analyzing the hope distance of the received signal and the transmitting signals. The output is given into destination of the received signal. The destinations of the received signals, it consists of m cross m channel matrix from the relay to destinations, is representing the noise vector at the destination of k. We assume that the eliminating of channel matrix h of l of I and g of k of l and noise vector drawn from an independent and independently distributed complex Gaussian distribution with zero mean and unit variance. Furthermore, we assume that the relay operated in full duplex mode and channel knowledge is assumed and all relay nodes, while not tably all source node and need not to land channel efficient values. The output is given into DOF. It is called as degrees of freedom. The degrees of freedom is spanning channel is used to achieving the probability of the error message. It is representing the channel achievable rate ratio. The output is given into receiver. It is considered to the transmitting signal is received the output of the signal. First select the main.m and run the file. Enter the channel user group. We allocating the two group. And the relay channel hope output will be display and the transmitting signal output will be display, splitting channels will be output will be display and the received signal channel will be output will be display. Another enter the input of the values to input. The output will be performed, the DOF performance output will be shown. The figure 1, it will be displaying the relay channel hope. It is performing the distance of the calculations, the transmitting of each channel user, first user, second user, third user, fourth user, fifth, sixth up to 10 user. We have using the channel allocation of relay channel hope. The figure 2 considered for transmitting signal. It is represented for timing of each signal frequency levels and depends upon the timing and frequency of the levels of individual user. The performance of the transmitting signal will be shown. The figure 3 is consists of splitting of channels. It is a several amplitude consisted for 1 to 5 users. It can be splitting the each signal into depending upon the time consuming of level each individual user allocating the channel level condition will be checked. Figure 4 indicating the receiver signal for one channel level. It is represented for signal level of the output of the received signal will be indicating of each signal of the amplitude and time of level will be displaying. The DOF performance the individual user of capability of time will be assumed will be distance will be calculated. Thank you.